So we saw what systems of equations look like on a graph, and we're able to identify how many solutions it has based on whether or not the graphs intersect. Now we're going to take a look at just the equations of our lines to see if we can tell by the slopes whether or not our lines will intersect. So if the lines have the same slope but different y-intercepts, they'll be parallel, which means they will never intersect and they'll have no solution. If the lines have the same slope and the same y-intercept, they're the same line and they'll have many solutions. And if the slopes are different in any way, then the lines will intersect and we'll have one solution. Our first system, the first equation is already solved for, so we can identify the slope right away for our first equation. Remember, the slope is the coefficient of x, or the number that's being multiplied by x when y is solved for. So looking at our second equation, we do not have y alone, so we cannot tell what the slope is just yet. We'll start by subtracting 3x from both sides. Now remember, 14 and negative 3x are not like terms. We cannot actually subtract them. They both have to have a variable, or they both have to be regular numbers in order to combine them. The 3x's cancel on the left, leaving us with negative 9y. Don't lose track of those negative signs. I'm going to put the negative 3x first because we're used to seeing these in mx plus b form. To finish solving for y, we'll divide everything by negative 9. Keeping track of your negative signs. The negative 3 divided by negative 9, the negatives will cancel. 3 over 9 simplifies to 1/3, dividing each of those by 3. And 14 over 9 does not simplify, but that positive over the negative will give us a negative y-intercept. Remember, it's okay that we got a fraction for a y-intercept. We're not graphing these. We're just analyzing what those equations look like. The slope of this line is 1/3, which is different from the slope of the first line, so these will intersect and have one solution. Our next set of equations, neither one of these are entirely solved for y, so we'll take a look at this first one, canceling that 6x from both sides, leaving us keeping track of those negative signs with negative 3y equals negative 6x plus 8. To finish getting y alone, we'll divide everything by negative 3. Again, keeping track of those negative signs as we divide. Negative divided by a negative is positive. 6 divided by 3 is 2. Positive divided by a negative is negative, and 8/3 does not simplify. That second equation is in point-slope form. We'll start by distributing that 2. Y equals 2x minus 2 plus 4, and then we'll combine our like terms. The negative 2 plus 4 gives me a positive 2. The slope of this line, what I'm multiplying by x, is 2. And the slope of that first line that I solved for is also 2. So this is a case where now we need to take a look at those y-intercepts. The y-intercept of my blue line is different from the y-intercept of my purple line. So these two lines are parallel. They will not intersect, so they have no solution. Taking a look at that one more time, we've got a similar setup as last time. So we'll rewrite that first equation so we can solve for y. Canceling that 4x first. Not losing track of our negative signs, we have negative y equals negative 4x minus 5. Dividing everything by that coefficient of y, negative 1, we're left with y equals 4x, all of those negative signs cancel, plus 5. Our second equation, point-slope form, so we'll distribute that 4. And combine our like terms to get 4x plus 5. Notice that the slope and the y-intercept of these lines are the same. So they're the same line, so they have many solutions. And finally, we'll practice setting up systems from a word problem again. Our first sentence says tickets for a concert cost $10 each if you order online, but you pay a service charge of $8. So we'll start off by identifying our variables. First of all, we're going to be buying tickets. So we'll say T is the number of tickets that we purchase. And whenever we buy tickets, we're concerned about our total cost. So we'll let C equal the total cost of our order. If we order online, our total cost is $10 times the number of tickets we choose to buy, plus we have to pay that service fee of $8 for ordering online. Our second sentence tells us that tickets are $12 each at the door, no service charge. So our total cost for purchasing tickets at the door is $12 times the number of tickets we buy. And finally, you have two you-try questions. The first one, solve for y and analyze those slopes and the y-intercepts if you need to. And the second one, practice setting up a system of equations.